Big problem. Roughly 90% of the plastics we use become waste. It's polluting our oceans, our lands, and transforming habitats. But in areas like medical care and sterile food packaging, plastics are essential. What if the plastics could be engineered for efficient, closed-loop recycling to allow for infinite reuse? Big problem. We're finding more cancer today than ever before. Early detection is great news for patients because it affords more treatment options. But what if we could design our immune systems to detect and fight cancer on its own, before patients even know they're sick? Big problem. There's a growing concern about a shortage of clean water in the very near future. This could devastate populations in areas already saddled with geopolitical instability. What if technology could be used to expand potable water resources over the next few decades? As an engineer at UChicago, you consider these big problems, and many others, to guide research and uncover solutions. And as it turns out, in thinking about big problems, you sometimes have to think very small. The Pritzker School of Molecular Engineering at UChicago takes the traditional approach of solving big problems and turns it on its head. It's a place where engineers and researchers from many disciplines collaborate to bring a molecular approach to solving big problems. In partnership with Argonne National Laboratory, PME is housed in the new state-of-the-art Eckhart Research Center. This facility, located in the heart of the UChicago campus, allows you to tackle global problems with a nano-level focus. A major in molecular engineering at UChicago prepares students for a variety of careers and leadership roles in our technology-driven world, including research, medicine, business administration, policy, and entrepreneurship. Your course of studies will reflect a strong background in math, physics, chemistry, and biology. Students are given the opportunity to choose a track to further specialize within the major, either the biology track, the chemical and soft materials track, or the quantum track. These engineers develop laboratory skills through hands-on experience and non-technical skills through further coursework. Any student admitted to the college and completing the prerequisites can pursue a major or minor in molecular engineering. Okay, back to the big problems. How do we solve them? While this question is still being answered, we do know it will take collaboration, advanced research facilities, and expert scientists well-versed in liberal arts, the kind being trained at UChicago's Pritzker School of Molecular Engineering. For next-generation plastics, we could take a cue from Mother Nature and design polymers with controllable methods of selective dismantlement. This approach would initiate the breakdown, followed by the efficient regeneration of materials with identical performance characteristics to the virgin plastics. Imagine the life cycle, plastics in a truly circular economy. Could we engineer molecules to help human bodies fight disease? Our immune systems are made up of molecules, and our ability to protect against and fight infections, allergies, cancer, and autoimmune diseases depends on these molecules. Imagine if we could govern this network through the molecules we engineer. Ultra-sensitive quantum sensors could detect biological and chemical changes at the molecular level and impact how we diagnose and treat disease. What about that molecule important to all life on Earth? Water. We need water to live, but in many places water access is limited or contaminated. As our climate changes, water access will continue to affect the lives of billions of people. PME researchers are working to design material systems that use a pioneering, biologically inspired strategy to develop water purification systems. Other research includes ways to extract useful or polluting elements, including uranium, lithium, and phosphorus from sea or wastewater. Molecular engineering is a continuation of the UChicago tradition of scientific breakthroughs. The 7 Nobel Prizes in chemistry and 29 in physics awarded to UChicago's faculty, students, and alumni are a testament to this proud legacy in the sciences. Our history is one of innovation with discoveries ranging from Ian Foster and grid computing, the modern-day cloud, to Enrico Fermi and the first nuclear reactor. But this long history of breakthroughs isn't just history, it's taking place here, every day. The Pritzker School of Molecular Engineering's collaborative and interdisciplinary approach to engineering builds on the strong liberal arts education at UChicago and our profound tradition of scientific innovation. Our core curriculum helps engineers ask the right questions and articulate their solutions. United by the liberal arts education and strong commitment to research, UChicago's molecular engineers learn to approach problems from multiple perspectives and devise creative, new solutions. We might not know exactly how we're going to create infinite plastic, or if we might ever completely cure cancer, or how the water resources of the future will be harvested. But we know that the next generation of engineers to tackle these problems will think differently. Equipped with a liberal arts background and knowledge and research skills imparted by leaders in the scientific community, UChicago engineers will be solving the big problems of the future, starting at the molecular level.